You ever get the feeling you're being watched? Not by a person. Not by something you can see or name. Just the sensation that somewhere, out there, something is paying attention to you. Now imagine that feeling, but it's not you being watched. It's everything. Every galaxy. Every star. Every atom in a region of space so vast it contains hundreds of thousands of galaxies. All of them moving. All of them being pulled toward something we can't see. We call it the Great Attractor. And here's the uncomfortable part. We have no idea what it is. I'm not talking about a mystery we'll solve next week with a new telescope. I'm talking about a genuine cosmic blind spot. A thing so massive it's dragging our entire galaxy, our entire galactic neighborhood, through space at over 1,000,000 miles per hour. And we can't look directly at it. We can't see it. It's hidden behind the densest part of our own Milky Way, a curtain of stars and dust so thick it might as well be a wall. So we know it's there. We can measure its pull. We can see what it's doing to everything around us. But we can't see it. That's the Great Attractor. A ghost in the machine of the universe. A destination we're hurtling toward whether we like it or not. And tonight, I want to tell you about it. Not because I have answers. I don't. Nobody does. But because sometimes the most profound thing you can do is sit with the discomfort of not knowing. Of being pulled by forces you can't control. Of moving through space and time towards something you'll never understand. Let me start with something you probably don't think about. You're moving right now. I mean really moving. Not just rotating with the Earth, though you are at about 1,000 miles per hour at the equator. Not just orbiting the Sun, though you are at 6,000 to 7,000 miles per hour. Not just rotating with the Milky Way galaxy, though you are at 500,000 miles per hour. No! You're also being pulled. Dragged, actually. Along with the Sun, the Milky Way, and hundreds of thousands of other galaxies, toward a point in space about 250 million light-years away. You're falling. We all are. Toward the Great Attractor. And the wildest part? You can't feel it. None of us can. Because everything around us is falling too. Your body, your bed, the air in your room, the Earth, the Moon, the Sun, all of it moving together in the same direction at the same speed. So relative to you, everything feels still. But it's not. This moment, right now, as you're lying here listening to me talk about invisible cosmic forces, you're traveling through space faster than any jet, any rocket, any object humanity has ever built. And you have been your entire life. Every person who's ever lived has been falling toward the Great Attractor, and most of them never knew it existed. Does that change anything? Does it make your day tomorrow different? No. Of course not. The bills still need to be paid. The dishes still need to be washed. Life goes on. But somewhere in the back of your mind, maybe it shifts something. Maybe it reminds you that the things you worry about, the mistakes you made, the things you should have said, the future you're anxious about, all of it is happening on a planet that's being pulled through space by a force we don't understand. And somehow, that makes it feel smaller. Not unimportant. Just smaller. The Great Attractor was discovered by accident. Isn't that how the best things always happen? In the 1970s, astronomers started noticing something weird. Galaxies weren't behaving the way they should. According to the prevailing understanding of cosmology at the time, galaxies should be moving away from each other uniformly because the universe is expanding. The Big Bang set everything in motion, and everything should be coasting apart, more or less evenly. But that's not what they saw. Galaxies in our local region of space, what we call the local supercluster, were moving in strange ways. They had what's called peculiar velocities. Not peculiar as in odd, though they are that too. Peculiar as in deviating from the expected motion due to the expansion of the universe. Think of it like this. Imagine you're on a raft in a river. The river is carrying you downstream. That's the expansion of the universe. But then you notice your raft is also drifting sideways, toward the riverbank. Something else is pulling you. Something besides the current. That's what astronomers saw. Galaxies drifting. Being pulled. In 1986, a team of astronomers led by Donald Lynden-Bell and others published a paper with a title that still gives me chills: Spectroscopy and Photometry of Elliptical Galaxies. A large-scale streaming motion in the local universe. Large-scale streaming motion. What a phrase. It sounds so clinical. So detached. But what it really means is this. We're all going somewhere, and we don't know why. They calculated the motion. They triangulated the direction. And they realized that our galaxy, along with thousands of others, is being pulled toward a specific region of space in the direction of the constellations Hydra and Centaurus. They called it the Great Attractor because, well, what else do you call an invisible thing pulling millions of galaxies toward itself? But here's where it gets frustrating. The Great Attractor sits in what astronomers call the Zone of Avoidance. The Zone of Avoidance. Doesn't that sound ominous? Like something out of a science fiction novel. A forbidden region. A place you're not supposed to look. But it's not forbidden by law or choice. It's forbidden by geometry. See, we live inside the Milky Way galaxy. Our solar system sits about 2/3 of the way out from the galactic center, embedded in one of the spiral arms. And when we look out into the universe, we have a clear view in most directions. We can see other galaxies, distant quasars, the cosmic microwave background. But when we look toward the center of the Milky Way, we're looking through the thickest, densest part of our own galaxy. Billions of stars. Massive clouds of gas and dust. All of it blocking our view like a fog. And wouldn't you know it, the Great Attractor is right behind that fog. It's like trying to see through a forest while standing in the middle of it. The trees are in the way. And no matter how good your telescope is, you can't see through solid matter. So we're left with this maddening situation. We know something massive is out there, pulling us toward it, but we can't see it directly. We can only infer its existence from the motion of everything around it. Imagine being blindfolded and feeling yourself being pulled across a room. You don't know what's pulling you. You don't know how big it is. You just know it's strong. And you're moving toward it whether you want to or not. That's where we are. Cosmically speaking. For years, astronomers tried to map the Great Attractor indirectly. They measured the motion of galaxies. They used radio telescopes to peer through the dust. They built computer models to simulate what kind of mass distribution could cause the observed motions. And they came up with a picture. A fuzzy, incomplete picture. But a picture nonetheless. The Great Attractor, they concluded, is probably a massive concentration of galaxies. Not a single object, but a region of space where galaxies are unusually dense. Think of it like a cosmic traffic jam. All those galaxies, packed together, create a combined gravitational pull strong enough to influence galaxies hundreds of millions of light-years away. The estimated mass? Somewhere in the range of tens of thousands of times the mass of our Milky Way galaxy. That's a lot. That's enough to bend space-time. Enough to drag entire galaxy clusters toward it. But then, in the late 1990s and early 2000s, something strange happened. Astronomers developed better tools. Better telescopes. Better ways to peer through the zone of avoidance. And when they finally managed to get a partial glimpse behind the cosmic curtain, they found something unexpected. The Great Attractor wasn't alone. Beyond it, even deeper in that hidden region of space, there was something bigger, much bigger. They called it the Norma Cluster. And beyond that, they found an even larger structure, the Shapley Supercluster, a mind-boggling collection of thousands of galaxies, sitting about 650 million light-years away. And here's the kicker. The Great Attractor itself is being pulled toward the Shapley Supercluster. We're not falling toward the Great Attractor. We're falling with it. Both of us, along with everything in our local region of space, are being pulled towards something even more massive. Something even farther away. It's like being in a river, thinking you're drifting toward a whirlpool, only to realize the whirlpool itself is being carried by an even stronger current toward a waterfall you can't see yet. Layers upon layers. Mysteries within mysteries. The universe pulling itself into structures so large we can barely comprehend them. And all of this motion, all of this cosmic choreography, is happening on timescales so long that from our perspective, it might as well be standing still. The Great Attractor is 250 million light-years away. Even moving at over 1 million miles per hour, it would take us billions of years to get there. Long after the sun has died. Long after Earth is gone. Long after any trace of human civilization has been erased. We'll never see it up close. We'll never know what it looks like. We're passengers on a journey we didn't choose, heading toward a destination we'll never reach. And yet, we're going anyway. There's something poetic about that. Something almost comforting. In a universe that often feels random and chaotic, there's a structure, a flow, a direction. We might not understand it. We might not be able to see where we're going. But we're moving. Together. As part of something larger than ourselves. Your problems, the ones keeping you up right now, the ones circling in your mind like vultures, they're real. They matter. I'm not going to tell you they don't. But they're happening on a rock that's falling through space. Pulled by invisible forces toward a destination billions of years away. And somehow, that context, it changes things. Not the problems themselves, but how big they feel. How much weight they carry. Because if the entire Milky Way galaxy, with its 400 billion stars, its countless planets, its unimaginable complexity, if all of that can be pulled across the universe by forces it can't see or control, maybe it's okay that you feel pulled too. By forces you don't understand. Toward futures you can't predict. Maybe that's just what it means to exist. The thing about invisible forces is that they shape everything, even when we don't notice them. Gravity, time, culture, expectation. We spend our lives being pulled in directions we didn't choose, by things we can't see, and most of the time we just call it life and move on. But every once in a while, you stop. You look up. And you realize, I don't actually know why I'm going this way. The Great Attractor forces that question on a cosmic scale. And the answers, or lack of them, tell us something profound about what it means to search for truth in a universe that doesn't owe us clarity. Let me tell you about the astronomers who first started piecing this together. Because their story is, in a lot of ways, our story. In the early 1980s, a group of researchers called the Seven Samurai, yes, that was their actual nickname, set out to map the peculiar velocities of galaxies. The team included Sandra Faber, David Burstein, Roger Davies, and others. They weren't looking for the Great Attractor. They didn't even know it existed yet. They were just trying to measure how galaxies were moving. Simple question. Brutal methodology. Here's the problem. Measuring a galaxy's velocity is hard. You can measure how fast it's moving away from you. That's relatively easy, thanks to redshift. Light from distant galaxies gets stretched as they move away, shifting toward the red end of the spectrum. The faster they recede, the redder the light. But that only tells you motion along your line of sight. It doesn't tell you if the galaxy is also moving sideways or being pulled somewhere else. To figure that out, you need to know the galaxy's actual distance, not just its recession velocity. And measuring cosmic distances is notoriously difficult. There's no cosmic tape measure, no mile markers floating in space. So the Seven Samurai developed a technique. They studied elliptical galaxies, those smooth, featureless blobs of stars, and discovered that there's a relationship between how bright a galaxy is and how fast its stars are moving inside it. Brighter galaxies have faster internal motions. If you could measure that internal motion, you could estimate the galaxy's true brightness. And if you knew its true brightness, you could compare it to how bright it appears from Earth and calculate its distance. It was indirect. It was messy. It required painstaking observations of hundreds of galaxies. But it worked. And what they found shook them. Galaxies weren't just moving away from us due to the expansion of the universe. They were also streaming, flowing, being pulled in a specific direction by something they couldn't see. At first, they thought it might be a mistake. Maybe their distance measurements were off. Maybe the relationship between brightness and velocity wasn't as tight as they thought. But the more galaxies they measured, the clearer the pattern became. Something out there, something massive, was pulling everything toward it. Donald Lynden Bell, a British astrophysicist, took their data and ran with it. He calculated the direction of the pull. He estimated the mass required to cause such motion. And he gave it a name, the Great Attractor. The name stuck because it perfectly captured the mystery. Not the thing pulling us or the massive object in Hydra Centaurus. No, the Great Attractor. Capitalized. Ominous. Like a character in a cosmic thriller. But naming something doesn't mean you understand it. Over the next decade, astronomers built better instruments. They launched satellites above Earth's atmosphere to avoid the distortion of our air. They used radio waves and infrared light to peer through the dust in the Zone of Avoidance. And slowly, piece by piece, they started to see what was hidden. In the 1990s, the 2-micron all-sky survey, 2MASS, mapped the entire sky in infrared light. Infrared can penetrate dust clouds that block visible light. It's like using thermal imaging to see through fog. And when they looked at the Zone of Avoidance in infrared, they found galaxies. Hundreds of them. Clustered together in a region called the Norma Cluster. This was progress. Finally, after years of inference and guesswork, they could actually see part of what was pulling us. But here's the problem. The Norma Cluster wasn't big enough. The mass they observed didn't match the gravitational pull they'd calculated. There was a discrepancy. A gap. Either their calculations were wrong, or there was more mass out there they still couldn't see. Dark matter, probably. That invisible stuff that makes up most of the mass in the universe but doesn't emit light. It's everywhere, lurking in the halos of galaxies, holding galaxy clusters together through gravity alone. But even accounting for dark matter, the numbers didn't quite add up. Something was missing. And then they looked deeper. Farther. Beyond the Great Attractor itself. And that's when they found the Shapley Supercluster. If the Great Attractor is a traffic jam, the Shapley Supercluster is the entire highway system. It's one of the most massive structures in the nearby universe, over 8,000 galaxies, all bound together by gravity, sitting about 650 million light-years away. And here's the truly disorienting part. The Great Attractor is moving toward it. We're not being pulled by the Great Attractor. We're being pulled with it. Both of us are falling toward the Shapley Supercluster. Along with the Virgo Supercluster. Along with everything in this corner of the universe. It's like those Russian nesting dolls. You open one mystery, and there's a bigger mystery inside. The cosmologist Brent Tully, one of the astronomers who spent decades mapping these structures, described it like this: we're part of a basin of attraction. Imagine a landscape with valleys and hills. Everything rolls downhill, toward the lowest point. The Shapley Supercluster is the lowest point in our region of space, and we're rolling toward it. We're not special. We're not being singled out. We're just obeying gravity, following the curvature of space-time, doing what everything does. But it doesn't feel that way, does it? It feels significant. It feels like there should be a reason, a purpose. There isn't. There's just mass, and time, and the cold, indifferent mathematics of general relativity. I think that's what unsettles people about the Great Attractor. It's not that it's mysterious. Plenty of things in the universe are mysterious. It's that it reveals how little control we have. How much of existence is just happening to us. You didn't choose to be born on a planet orbiting this star in this galaxy. You didn't choose to be part of a cosmic structure flowing toward a supercluster you'll never see. You're just here, moving, being pulled. And maybe that's okay. There's a Zen teaching I've always liked. It goes something like this: you cannot stop the waves, but you can learn to surf. You can't stop the Great Attractor. You can't slow it down or change its course. You can't opt out of the cosmic flow. But you can be here, now, aware of it, marveling at it. That's the gift of consciousness, really. Not control, not understanding, just awareness. The ability to know you're part of something larger, to look at the motion of galaxies and feel a connection to it, to realize that the same forces pulling clusters of stars across the universe are, in their own small way, pulling you too. Toward what? Who knows? Maybe nothing. Maybe everything. But you're moving. And that's something. In 2014, a team of astronomers published a new map of the universe. Using data from thousands of galaxies, they traced out the large-scale structure of the cosmos in our neighborhood. They identified superclusters, voids, filaments, the cosmic web, they call it. And they found that the Shapley Supercluster isn't the end of the story either. It's part of an even larger structure they named Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea is a supercluster of superclusters. It contains over 100,000 galaxies, including our own Milky Way. And it's all flowing together, like water draining toward a basin. The Great Attractor sits near the center of Laniakea. Not at the center, nothing's ever that neat, but close enough that it's a major gravitational hub. A waypoint on a journey that spans hundreds of millions of light-years. And here's the beautiful part. They mapped it by tracing motion. Not by looking at where things are, but by looking at where they're going. Because in the end, that's what defines us. Not our position, our trajectory. You're not defined by where you are right now. You're defined by where you're headed, what you're moving toward, even if you can't see it yet, even if you don't know what it is. The Great Attractor taught us that. It taught us that you can know something exists without seeing it, that you can be certain you're moving without knowing the destination, that the universe is full of invisible forces shaping everything, and the only real question is whether you'll fight them or flow with them. I know which one sounds easier, but I also know which one feels harder. Because flowing means letting go. And letting go means admitting you were never in control to begin with. And that's terrifying. But it's also freeing. If you're not in control, then you're not responsible for everything. If invisible forces are pulling you, then maybe some of the directions your life has gone weren't your fault. Maybe some of the outcomes weren't failures. Maybe they were just gravity. The Great Attractor doesn't judge the galaxies it pulls. It doesn't have favorites. It just pulls. And the galaxies just move. No guilt. No shame. No existential crisis. Just motion. Maybe we could learn something from that. There's a thought experiment I've been sitting with lately. It goes like this. What if you could see the Great Attractor? What if tomorrow, scientists found a way to peer through the Zone of Avoidance, to cut through all that dust and gas, and finally reveal what's been pulling us all along? What would change? Would your mortgage disappear? Would your relationships suddenly make sense? Would the ache in your chest at 3 in the morning, the one that has no name, no clear cause, would that go away? No. Of course not. Knowing wouldn't change the pull. We'd still be moving toward it. Still falling through space at over 1,000,000 miles per hour. The only difference is we'd have a picture. A face to put to the force. And I wonder if that would actually make it better or worse. Because sometimes the not knowing is the point. Sometimes the mystery is what keeps us searching. What keeps us curious? What keeps us humble enough to admit that the universe doesn't owe us explanations? The Great Attractor has been pulling us for billions of years. It'll keep pulling us for billions more. And in all that time, across all that distance, it's never once asked for our permission. Never once checked if we were comfortable with the direction. It just pulls. And we just go. And somehow, against all odds, life emerged anyway. On at least one small planet, circling an unremarkable star, in a galaxy being dragged across the universe by forces it can't control, consciousness happened. You happened. Not because the Great Attractor planned it. Not because there's some cosmic purpose we're fulfilling. But because the conditions were right, for just long enough, for atoms to arrange themselves into patterns complex enough to wonder why they exist. That's it. That's the whole story. And it's enough. You know what strikes me most about studying cosmic structures like this? It's not the scale. It's not the distances or the masses or the mind-bending numbers. It's the patience. The Great Attractor has been doing its thing for eons. Slowly gathering galaxies. Slowly warping space-time. Slowly pulling everything toward itself with the quiet, persistent inevitability of gravity. It's not in a hurry. It doesn't have deadlines. It doesn't worry about productivity or efficiency or whether it's doing enough. It just exists. And in existing, it pulls. Compare that to how we live. How we rush. How we stress about time running out. How we lie awake worrying that we're not moving fast enough, not achieving enough, not becoming who we're supposed to be quickly enough. Meanwhile, the galaxy we live in is taking hundreds of millions of years just to drift toward a structure we can barely see. And it's fine with that. The universe is fine with that. Maybe we could be fine with that too. I'm not saying you should stop trying. I'm not saying ambition is pointless or that goals don't matter. I'm just saying, maybe the timeline you've set for yourself is arbitrary. Maybe the pressure you're feeling isn't coming from the universe. It's coming from you. And maybe you could ease up. Just a little. The Great Attractor isn't judging your progress. Neither is the Shapley Supercluster or Laniakea or the Milky Way. They're all just moving. Slowly. Patiently. Toward destinations they'll reach in timescales that make human lifetimes look like heartbeats. And if they can be patient, maybe you can too. There's another layer to this that I haven't mentioned yet. Something that deepens the mystery even further. In the late 1990s, astronomers discovered that the expansion of the universe is accelerating. Not slowing down, like you'd expect if gravity was the dominant force. Accelerating. Something is pushing space itself apart. We call it dark energy, though that's just a placeholder name for we have no idea what this is. Dark energy makes up about 68% of the universe. Dark matter, another mystery, makes up about 27%. That leaves only 5% for normal matter. The stuff we can see. The stuff we're made of. We're a rounding error in the cosmic budget. And we're trying to understand the other 95%. So here's the situation. The universe is expanding, pushed apart by dark energy. But locally, within galaxy clusters and superclusters, gravity still dominates. Structures like the Great Attractor and the Shapley Supercluster are still pulling things together, even as the space between superclusters stretches. It's a tug of war. Gravity pulling inward. Dark energy pushing outward. And we're caught in the middle, watching it play out on scales we can barely measure. Eventually, dark energy will win. Billions of years from now, the expansion will overcome even the strongest gravitational pulls. The superclusters will drift apart. Galaxies will become isolated islands in an ever-expanding ocean of space. But not yet. Not for a long, long time. For now, we're still being pulled. Still part of the flow. Still connected to structures larger than we can see. And there's something bittersweet about that. About knowing that this moment, this era of cosmic structure, of galaxies clustered together, of great attractors pulling streams of matter across hundreds of millions of light-years, this is temporary. One day, the universe will be so spread out, so diffuse, that structures like this won't exist anymore. Galaxies will be alone. Truly alone. Separated by distances so vast that light from one will never reach another. But right now, we're together. Part of something. Flowing as a group toward a common destination, even if we don't know what it is. And maybe that's all community ever is. A temporary pulling together in a universe that's mostly pulling apart. A brief moment of shared direction before entropy wins and everything drifts into isolation. So maybe the question isn't what is the Great Attractor? Maybe the question is what does it mean that we're all being pulled together? Because it means we're not alone. Not really. Even though we're separated by distances that make human travel impossible. Even though we'll never meet the beings on planets in other galaxies being pulled alongside us. If there are any, we're still moving together. Still part of the same flow. And if galaxies can be connected across hundreds of millions of light-years by nothing but gravity and shared motion, then maybe you're more connected than you think too. To the people around you. To the strangers you'll never meet. To everyone who's ever felt pulled by forces they can't see. We're all falling toward something. Some destination we can't name. Some future we can't predict. And that's okay. Because the falling isn't the problem. The falling is just physics. Just gravity doing what gravity does. The problem is when we forget we're all falling together. When we think we're alone in the dark, being pulled somewhere we don't want to go. But you're not alone. You're part of Laniakea. Part of the flow. Part of a cosmic structure so large it contains 100,000 galaxies, all moving together, all headed somewhere beyond our sight. And if they can do it, if they can drift through the void for billions of years without knowing where they're going or why, then so can you. One more day. One more breath. One more moment of being pulled towards something you can't see. That's all any of us can do. The Great Attractor will keep pulling. The Shapley Supercluster will keep gathering. Dark energy will keep pushing. And somewhere in the middle of all that cosmic machinery, on a small planet that's barely a speck in the grand scheme of things, you'll wake up tomorrow, and you'll make breakfast, and you'll go about your day, and you'll feel the pull of invisible forces, deadlines, expectations, desires, fears, and you'll move through them as best you can. Just like the galaxies. just like everything that's ever existed, pulled by forces you can't control, moving toward destinations you can't see, but moving nonetheless. And maybe, just maybe, that's enough. The universe doesn't need you to understand it. It doesn't need you to have all the answers. It just needs you to be here, to exist, to move. The Great Attractor will do the rest. So let it pull. Let it guide. Let it take you where it's taking everything else, toward mystery, toward wonder, toward futures we can't imagine. And trust that wherever you're going, you're not going alone. We're all falling together, toward something we can't name, in a universe that doesn't explain itself. And somehow, that's beautiful.